color. You round up to the
Nearest
next
integer.
integer. Yeah, and when I say next, you're going to the right, like on a number line,
Uh-huh.
to the right. Okay, so let's do some easy examples. Let's do 20.4. Okay, if 20.4 on a number line, if that's 20.4, this is going to round to 21 because it's the next integer to the right, to the right. Okay, does that
Mhm.
make sense?
Yeah.
Now let's go to a more challenging problem. Like let's say, there's zero, there's -1, and I give you -0.3, which is right there. It goes to the right. So what does it round to?
0.
Yes. Okay. And so you've got a problem here, a -1.5. And that's why it's really important to graph it, because then you'll see, okay, if that's -1 and that's -2, -1.5 is right there. It goes to the right, which would be -1.
Okay.
Now, if it's a whole number, then you keep it. Or not a whole number. If it's an integer, that's not correct. If it's an integer, you keep it. So for example, -3 becomes -3. 215 becomes 215.
Okay.
Is that all right?
Yeah.
Great. So as a side point, I have no idea why this is even covered in math. I mean, it's actually more of a programming thing than a math thing, but
Hmm.
it's like they always throw this greatest integer business in there, and it's just not useful. Um,
Yeah.
but that's, nevertheless, that's what we've got. All right, number two is a piecewise graph. Now, I don't remember us doing any piecewise graphs. Is this something that you feel like has been emphasized in the class?
I mean, I've definitely seen it before, but I don't know if I'd say it's emphasized.
In this class, like in the last few weeks, you've seen this?
Me personally, no.
Okay. Well, I don't know what to say because it's like, well, we should do it, but all right. The way to do this is it's really three graphs in one. And you start with the most left, the top one there, x squared minus one. And I like to make a table. Okay, so x and y, and you start at whatever number they're starting at, which is 0. Okay. And you make a note that this is an open circle at 0. It's an open circle because it's less than goes with this one, greater than goes with it. If it's greater than or equal to or less than or equal to, that's a filled-in circle. And then
Uh,
you need a few points. So you're going left. Like left of 0 means you're going -1, -2. So you want to build a little table to get some points. And so you have to put each of these x values into this equation. All right. Would you attempt to do that for me, please? Would you put 0 in for x, -1 in for x, in the x squared part, and tell me what you come up with here? And you're allowed to use a calculator, of course.
mm, -1 for the first one. Um, -3 for the second.
Okay, so for the second one here, it's parentheses -1 squared minus 1. -1 squared means to multiply -1 by itself.
So 1 or
Minus 1
0.
becomes 0. So try that for the next one here.
1.
-2 squared means to multiply -2 by itself. So -2
Or
times -2.
uh 3.
Final answer 3. Good. So now we're going to go to the graph. 0, -1 is an open circle. -1, 0 is filled in. -2, 3 is filled in. And you have to go that direction. You're like, all right, I'm going that direction with it. There. Like you don't keep going. There's like a boundary here where it's only good for x less than 0. Is that okay?
Yeah.
All right. Now we're gonna do this middle one here. This middle one is good from 0 to 1. It's an equation of a line. I'm gonna rewrite it because we're running out of room here. 2x minus 1, 0 less than or equal to x less than 1. So again, I like to build a little table, x and y. Start with the leftmost x value. This is going to be a filled in circle. And then at 1, it's an open circle. I write this so that I remember because I you can easily make mistakes here. So give me the y values after you put these numbers in, please.
Uh, -1 and 1.
Good. So we're going to go graph these. So we're going to put a dot filled in at 0, -1s. But at 0, -1, see how it's not filled in?
Yeah.
This is going to fill that in. Sometimes that happens. And then we've got
Okay.
another dot at 1, 1, but that's an open circle. Don't leave, don't like make it clear what you're doing. Don't try to play a game of like, well, I'm gonna kind of show if it's, oh, just make a decision and go with it. Yeah,
Okay.
be consistent here. Okay, so you've done all that. Now we do the last one. The last one is x plus 2 for x greater than 1. X plus 2 for x greater than or equal to 1. Yeah, you can probably tell I would color code these for sure if I could. We're gonna start at 1. That's a filled in circle. 2, and then maybe 3, a couple of points there. So give me the y values.
Let's see. 3, 4, and 5.
Okay. So 1, 3 is gonna be filled in. A couple more here, and then you got to make sure you go in the right direction like that. So what about this do you feel like would be difficult for you to do on your own?
Um, how'd you how'd you get the original like X numbers so that
It's
I
ba
plug in it?
it, yeah, it's based on the inequality here. So see how it says x less than 0?
Uh-huh.
I know to start at 0 and then is -1. See how -1 is less than 0, -2 is less than 0.
Oh,
We need
yes.
a couple of
Okay.
points. And then from 0 to 1, even though 1 is not included in red, we still like do it. We still use the ones even if they're not included. Like see how 0 was included here?
Mm-hmm.
0 to 1, 0 less than equal to x less than 1, we still include it. Um, Same thing on the right here, you know, start at 1, go out a few. Now, let's just say you're stuck. You're like, I don't remember how to do this. Well, do what you can. Like if you only know how to graph these two, then only graph those two. Do something, take a step in the right direction here.
Okay.
Are you allowed to use a graphing calculator on this one?
Yeah.
Oh, good. You can also try graphing um, that if you're really stuck, but it's meant to be done by hand. But
No.
it doesn't matter to me. If you can graph, you can graph. All right, this is a multiple choice here. That doesn't mean that's easy. It just means that they're trying to focus your answers here. It says describe the continuity of this function at x equals 3. All right, so there are 3 types of discontinuities. Let's go through each of them.
You know which
B,
you know which page this is on?
this is on first page.
Okay.
Yeah, first page there. You said B, it was either going to be A or B. I would prefer us doing quiz C because I think it's the most consistent with what like normally is asked, but
All right.
um, I don't know. You can always tell me, hey, Matthew, let's move on to another question if you want.
All right.
So a jump discontinuity looks like this. Like, let's say the graph comes down. This right here is considered a jump.
Yeah.
Okay. An infinite discontinuity is a vertical asymptote. So that's, you got a graph like this. Maybe there's a vertical asymptote here. It looks like this and it looks like this. So that is C. D, a point discontinuity looks like this. Like, let's say the graph's coming up. There's what's called a hole. It's called a hole.
Mhm.
And maybe it keeps going. Okay. All right. So the answer to this will be clear in a moment, but you have to know each of these to be successful in this class.
Right.
All right. So to do this problem, you have to first recognize that this is a rational function. Rational here just means it has a top and a bottom. Whenever the bottom equals 0, this is a vertical asymptote.
Okay.
Okay, so x squared minus 9, you set that equal to 0. And then you can either solve by factoring or using the square root formula. So the
Okay.
factoring approach, let's just look at that. This is difference of squares, so it becomes x minus 3, x plus 3 equal to 0. You set both of those equal to 0. X equals 3 and negative 3. If you use the square root method,
Uh-huh.
you would add 9 to both sides. X squared equals 9. You would take a square root of both sides. X equals plus or minus the square root of 9, which is plus or minus 3. Okay, so you
Right.
notice you get the same either way. Now, when the bottom is 0, that's a vertical asymptote. So you're supposed to know that combined with this up here to recognize that a vertical asymptote is an infinite discontinuity. So the answer is C.
Yeah.
Is that okay?
Yeah.
All right. Now you said you're allowed to use a calculator. Do you have your calculator handy?
Yeah.
Okay. I want you to graph. We did this last time, and it's okay to ask me questions. I want you to graph this right here. And I want you to use a standard window.
Just in the y equals. Or,
Yes. Yeah, you're gonna go y equals x to the sixth. You're gonna have to use the caret symbol, but I want you to try graphing that for me. And if you have questions, let me know. I'm happy to talk you through it if needed.
uh, just give me a parabola, like following the y-axis down, like all the way, and then stopping at 0 and then going back up.
Something like
Yeah.
that.
Yeah.
Okay, great. Great. Now, that's really important. To answer all of these questions, it's really important to have picture. Picture is worth 1,000 words, right?
Uh,
According to someone who said that. So the picture tells us a lot. The domain are the x's. Like, you're looking for things that are bad. Bad is like division by 0, square roots of negatives. You don't have any of that here. Nothing.
uh,
So the domain here is everything, all real numbers. Is that okay?
yeah.
the domain is typically always going to be this, like unless there's something else, unless there's an exception, just this is kind of the default to go to. Now for the range are the y's. Notice the graph does not go down forever. It goes up forever, up forever. What is the minimum y value? You kind of mentioned this because it looks like it hits the x-axis.
Yeah. Minimum y is y0.
Yeah, so it goes from 0 to infinity. Infinity always gets a parenthesis. But the number 0 could get a bracket. It gets a bracket if it's included. And it does include this number. All right, now the end behavior, this is you're doing two things. You're saying as x goes to infinity, which means to the right, going to the right forever. So you like, if you could trace your finger along the curve to the right forever, and you ask yourself where does it go? Well, it goes up forever. So up forever is positive infinity. So you would say as x goes to infinity, as x goes to the right forever, as you're going along the curve to the right forever, the function goes up forever to positive
Uh-huh.
infinity. Now, similarly, you got to go left. So you say as x goes to negative infinity, left, as you're going on the curve to the left, on the curve to the left forever, up, 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 up. Well, what happens to y? Y goes to infinity.
Okay. Is that negative infinity or?
Positive.
Oh,
It's
okay.
going up. Up is positive infinity. Right, so the next thing here, decreasing. So decreasing means it's going down and to the right. So there's a lot of definitions here to remember.
Okay.
So where is the graph going down and to the right? Well, you can see visually, like, well, it's over here, where it's in this direction. This also refers to the x's. So
Uh-huh.
it's all the x's until you get to 0. And you start from left to right. So this is minus infinity to 0, where it's decreasing. If it asked where it's increasing, increasing is when it's going up and to the right. Again, another definition. You can see that that is from 0 to infinity. Again, these are x values. And we
Okay.
really need to look at more graphs to get this in, but maybe you'll get this problem or something really similar to it, and it'll be exactly the same.
Yeah.
Okay. Any other questions on that before we go to even, odd, or neither?
No.
Okay. So there's a few ways to do even, odd, or neither. There is the graphical approach. There's which we can do. There is the functional approach. Do you remember what you guys did in class or how to best
uh,
help?
most likely functional.
Okay. So you're given a function which is x to the sixth. The first thing you do is evaluate f of -6. That means you're putting negative x in for x. So
Okay.
it's negative x to the sixth. This reduces to x to the sixth. The reason is that negative to a power of 6 becomes a positive. So there's kind of a rule. It's like -1 to an even power is always 1. -1 to an odd power is always -1. Now, if this is exactly the same as the original, you can then say that this is an even function, which it is. Now, this does not always work like this. Like it's not that, it must be even like that just happened to work in this.
Yeah.
So, keep that in mind. It's not that easy.
No.
Again, we'd want to spend a lot of time working on some examples and seeing if we can, dial in, how to do this for everything, but you know, we don't have time for all.
Yeah.
Any questions on that?
No.
Okay, we're going to do number 6 next because it's actually a lot like the one we just did.
All right.
Okay, use technology to graph f of x to the fifth plus 3x cubed minus 7x, then state whether f of x is even, odd, or neither, and then verify your answer algebraically. So I'd like you to graph this, please, and use a standard window. And I'll do the same here, and then we'll compare our results here.
Okay. Okay.
You have it graphed?
Yeah.
Does it look something like this in your window?
Yeah.
Okay, now what I want you to do is turn your calculator upside down. And does it look the same?
Yeah.
It does. So this one is going to end up being odd. Okay. So the trick, I'm a magician now. The trick is to turn your calculator upside down and see if it's the same. And it
Okay.
is. So that's for odd. For even, if you go back to even, imagine there's a mirror along the y-axis. Does it look the same on the left as the right?
Yeah.
Yeah. Or if you were to cut it in half, could you flip it over and it'd be the same? Yeah. So that's the other way to do it. Now, graphically, we've already kind of talked about how to do it graphically. So that's good. Now, algebraically, it is a little bit more involved. So just like before, you first determine f of negative x. Now, again, it's really important, we kind of saw this earlier, that you treat the variables as if they're in parentheses. Negative x to the fifth plus 3 negative x cubed minus 7 times negative x. And this is where that whole, you know, a negative x to an even and an odd comes into play.
All right.
So for example, here, the first one is negative x to the fifth, because a negative to the to an odd power is negative.
Right.
Now the middle term here, this negative x cubed becomes negative x cubed times positive 3 becomes minus 3x cubed.
All right.
The next one here, the minus 7 times negative x becomes positive 7x. All right, now, is this the same as the original? This is exactly the same as the original. X to the fifth plus 3x cubed minus 7x. This is exactly the same.
Um, no.
No, no. So it's not even. So the next thing you do here is you factor out -1 from everything. So you're dividing each of these by -1. So this becomes x to the fifth plus 3x cubed minus 7x. Now you ask the same question, is what is inside parentheses the same as the original? Is this part
Uh,
inside parentheses the same as the original?
no.
The original is x to the fifth plus
Oh
3x cubed
yeah.
minus 7x. Is
Yeah,
it the
no.
same? Yes. So if you get a yes, that means it's odd. But you could also do it, excuse me, the way that you're, where it said use technology and use the graph. All right, let's move. We're gonna skip 5. Um, let's uh let's do a few other problems here to see if we can get some full coverage of some things on your test. Um, okay, here we go. All right, describe the graph of g of x equals x minus 3 to the fourth as a transformation of x to the fourth. So one option to do this, option number 1, is to graph y equals x to the fourth, and then to graph, so that'll go in y1, the transformed graph like this. And I recommend doing that. I would graph this and then be like, well, what do I see? Do I see it moving up, down, left, right, stretch, shrink, all that stuff? Why don't you give that a try and tell me what you see?
You got like a parabola.
Say that again.
I got like a parabola on the right
Right.
side of
But
that.
what does this next one look like? Like it's like before and after. What's the transformation?
Oh, it moved to the right.
It's right three. And that's important. Like you have to be able to see that. Now, students are typically asked to do that, without graphing it, but I don't see any problem with graphing it.
Uh,
So any questions on that?
no.
Okay. So the next style of problem we're going to see is kind of going backwards. It's where the graph is given, and you have to kind of be like, well, what's different about this graph compared to the standard one? Okay, so the it's like, how do I go from what's the U-shaped graph here squared to this? And maybe you can say a few things in words, like what do you see here visually, you know, rather than we don't have to focus on the math quite yet, but visually, like what do you see that we could use?
Um, that it flipped and
Okay, so
moved
it's
to the
flipped.
left
That's
or
good.
right. Moved to the right one, I think.
Right one. Good. Okay. So based on what you saw in the last problem, how would you go right one on this?
Uh, X or parentheses X minus one square root of, or to the
Yeah.
power of four.
Good, 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 good. Yeah. So that's parentheses x minus one squared. The flip, any idea what that is?
No.
So that's putting a negative in front.
Okay.
So what I want you to do is graph this right here and make sure that it looks like this when you're done.
All right. Okay.
Does it look like this?
Yeah.
Okay, so you got it. Um, all right, let's talk about number 3 here. It says find the vertex of this function and state whether there's a minimum or a maximum. Can you tell me though, before you graph it, whether it's a minimum or a maximum based
Uh,
on,
maximum.
okay, so if a graph opens up, it has a minimum. So that looks something like this. If it opens down, It has a maximum. Go ahead and graph this and tell me which one it is. So I know I'm not asking you to do a lot of graphing, clear them out each time.
Oh, like if it's a minimum, will the vertex be at the bottom or?
Yes, good question. So the vertex, yes.
Um, minimum.
This one has a minimum. Okay. Now, do you remember from last time we did this a couple ways? We did second calc, and then there's a couple of options there. You can see that one of them is minimum.
Yeah.
Okay. So if you select the minimum, you should see something that says left question mark or left bound question mark. If not, I'll graph them to try and see if you can follow along here without.
Okay.
Do you see that left or not?
Left down.
Yes, left bound. So you
Yeah.
want to go somewhere left of it, like right there. We'll just say and hit enter. So get somewhere left of it and hit enter. Then it'll say right bound.
Yeah.
So you want to go somewhere right of it. You want to trace until you go to the right of it and hit enter.
Okay.
Then it'll say guess. And you'll hit enter again. And I want you to read to me the coordinates of the vertex, please.
Um, -3, -6.
Good. Very good. Okay. So if you can do all that, graphing it really isn't too bad. You've got this graph here that you're going to show. So -3, -6 right there. And then you're going to start graphing other points along there. So, these are going to be up here. Yeah. But anyway, so that's, and a rough sketch would be good. Something like that. Questions, thoughts on that?
No.
Okay. We're gonna go to number 4, which says to find the zeros of f of x equals 2x squared minus x minus 15. One option is to graph like we've been doing. I know you like that, but there's probably no way to show work. So the teacher may or may not accept that. So you might ask, like don't just be like, oh, I'm gonna graph it and hopefully I get the right answer. Like, well, might work. The preferred option here is to factor. And this is the A not equal to 1 type. This is the grouping problems. Do you remember anything
Okay.
about that from last time? We did some of this factoring last time.
I think so.
All right, so whenever the number in front is not a 1, which is what this means, A not 1, you have to take the first number and multiply it by the last. 2 times -15 is -30. So now you're looking for two numbers that multiply to -30, but add to -1. The reason it's -1 is that's the middle one there. So two numbers that multiply to -30, but add to -1. Can you think of those numbers, please?
Um, uh, not really.
Okay, so I'm gonna give them to you. It is 5 and -6.
Okay.
5 times 6 is 30, so one of them has to be negative. And then you're deciding, was it -5 and 6 or 5 and -6? Well, they have to add to -1. They have to add to -1. So what does that mean? Well, they're one apart, -1 apart here. So that's how you do this. Now you got to figure out which one pairs better. So what you're doing is you're breaking apart this -1x, and it's better if it's -6x plus 5x. And then you're bringing the other ones down here, 2x squared, like that. So now the first two, you find the GCF. The GCF. What is the GCF
Greatest
between
common
2x?
factor.
Say that one more time. Yes. Yeah.
Yeah.
Right. So what is the greatest common factor between 2 and 6? What number goes into both?
It's got
2,
2.
and then 2, and then there's 2x. So you're taking the 2x out of both. So that becomes x minus 3. You immediately write x minus 3 off to the side here, and you figure out what goes in the middle such that when you multiply in, you get back to the previous line here. Then it's really factoring twice, double factoring. These both have an x minus 3 in them, so you factor those out, bring down the 2x and the 5 like that. You're still setting this equal to 0 the whole time. And now you set each of these equal to 0 and solve for x. So x is 3. On the right here, you have to subtract 5. 2x equals -5, divide by 2, divide by 2. So you have x equals -5/2, and x equals 3. Okay, I know that was quick to finish there, but we do have to stop here